Day 3 of solving two-step equations. So today we're going to look at what happens when you have this negative variable right here, and specifically a negative t. I know that's given my classes some trouble. And then we're going to take a look at what happens if the entire equation is in a fraction rather. Okay? So what I know I've done with my students is I've looked at them and had them actually identify how many t we have here. Again, we have our equation and our variable is on the left side. We're identifying that. Now, what we have to identify then, again, is figure out how many this t is, because actually it's kind of tricky because we know by just combining like terms, this in fact is a negative t. And we know that because the sign in front of it is subtraction, or another way to say that is it's a negative sign. So what we're going to do again is we're going to balance as normal. So we want to get this negative t by itself, and in order to do that, we need to get rid of this positive 12. And the way we eliminate that positive 12 is, you guessed it, subtract 12, because we're using that opposite operation. And we want to get 0 over here again, which means on the right-hand side, we have to subtract 12 as well. We know that 12 minus 12 is 0. And then we know on the right-hand side that this 91 subtract 12, I know my kids have gone through and done this, where they make it 11, that's fine. I have no shame if you guys do that. So we have that positive 79, and then here's where it gets tricky. Is my guys, I know we've had to look at this and write in what number is really in front of that t. Realistically, that is a 1t, but because there's a negative sign in front of it, it's actually a negative 1t. So a lot of times we'll write in the negative 1 just to help us and figure out what to multiply or divide by in the end, because we don't want negative 1t. We want to have positive 1t. So we may actually get rid of that negative 1 sometimes, so we'll actually erase that and just make that negative t. Now what we have to do to get rid of this negative sign is divide by what number was really there, which in fact was negative 1. And even if I want to write that negative 1 up there, negative 1 divided by negative 1 is positive 1. We've earned positive t. And now 79 divided by negative 1. The only thing that really changes is the sign here is now, instead of this being a positive 79, now it's a negative 79. To check my work now, I have my equation, so I'm going to rewrite the 12 minus, and I'm going to put this in parentheses, this negative 79 is equal to 91. Now what my kids will do is they'll look at this negative times a negative. We'll either say, hey, that's negative 1 times a negative 79, which is positive 79. Or the other way we will do that is sometimes they'll look at it and say, look at that, I have two negatives back to back. That means I'm actually adding that, which in case would turn again into 12 plus 79 equals 91. 12 plus 79, again, is 91. Is that equal to 91? It is. Therefore, I'm correct. Now we're looking at the whole fraction piece, and what happens. This is a really tough thing I noticed that a lot of 7th graders have difficulty with, is what happens if the entire thing is a fraction. Here's what it actually means. Realistically, we talked about this with order of operations. That 9 plus x is all in the numerator, therefore meaning it's protected as its own little parenthesis. But if I wanted to split this whole thing up, I could. I could split this whole thing up, and realistically, I have 9 over 5 plus x over 5. That's just by definition, because the 5, we're not picking and choosing what we're dividing by 5 in this case, because it's the whole quantity, 9 plus x over 5. The problem is, this looks a lot more complex and is a lot harder to solve, because then you have to change this negative 8 around. If you're adding or subtracting from it, you're going to have to find common denominators, and that is just, for what I think, it's a little too much work to get there. We can get there in 2 steps. So here's how we're going to do that. In order to eliminate this 5 on the bottom, this actually means that we are dividing by 5. That's what that fraction bar actually means, and that's something that we've talked about before in my class. In order to eliminate this divide by 5, we're going to use rules of equations, and we're going to use that opposite operation, which is to multiply both sides. Now, in order to get rid of this divide by 5, that means I'm going to multiply both sides by 5. Now, on the left-hand side, though, I'm going to write 5 over 1. And here's why. For those of us that know how to cross-reduce in here, we know that 5 divided by 5 is actually 1. And this whole thing, this x plus 9, or excuse me, 9 plus x, actually just drops in to our next level of our equation. Now on the right-hand side, I have a negative 8 times 5, which is negative 40. And now it's just a one-step equation where I'm solving for x, because I do have that 1x. I have that 1x in there. And now I just have to get it alone by subtracting by 9. So then x is equal to, same signs in this case, so I know it's going to be a negative. I just add these together as a negative 49. And very quickly, before I go on, your code for today, for day 3, for the Google form, is actually the word reciprocal. Okay, make sure you spell that correctly. Reciprocal is your code word for today. Okay, now we're going to get moving on to the next step. So now we're going to check it very quickly. I'm going to substitute in this negative 49 right here for x. So I have 9 plus a negative 49 over 5. If I'm right, that should equal negative 8. I know 9 plus negative 49, different signs. I'm going to subtract and keep the sign of my higher number right here, which is that negative. So I have a negative 49 minus 9 is 40 over 5. And I know that, again, is just division, so negative 40 divided by positive 5. I have one negative, so that means my answer is negative, and that's equal to a negative 8. Therefore, I am correct in this result. Last example, and then we're going to get rolling into the Google form. All right, in order to get rid of this 3 in the denominator, I need to multiply both sides by 3. Obviously, if you're multiplying a whole number by 3, you can leave the 3 as a whole number. On the left-hand side, let's put that over 1. So I know my variable is obviously on this left-hand side. I'll draw that down the middle. 3 divided by 3 is 1, and this whole thing, v minus 8, may then drop in because that was all over 1. I'll evaluate the right-hand side. 11 times 3 is 33. So in this case, I have my 1v. I need to balance it and get it alone, so that means I have to add 8 to both sides. Therefore, v is equal to 41. Lastly, here's my check. So I'm going to substitute in this 41 for v, excuse me. So I have 41 minus 8 over 3. That should equal 11. Evaluate the numerator. 41 minus 8 is 33. Divided by 3 should equal 11. And I know 33 divided by 3 is 11, and that is equal to 11. Therefore, I am correct. So what you're going to do now, ladies and gentlemen, is you're going to go into the Google form, fill that out to the best of your ability, and utilize these notes as much as humanly possible.